Welcome to our communication system course. In those course, we have started in pulse. In the last class, we have already seen, and today we will talk from this point. And The sync function, we can see here that sync function goes the bandwidth for sync function goes to infinity. Okay, and our channel bandwidth is not infinity, but it is limited, so that we have one constraint, that channel bandwidth must be greater than equal to signal bandwidth. Okay, and signal bandwidth, here we can see that signal bandwidth is not limited, it is unlimited. It is going to minus infinity to plus infinity, that is frequencies lies between minus infinity to plus infinity, so that we have to some limiting this bandwidth, so that we can transmit the signal in uh, that channel. Okay, what will happen when signal bandwidth remains infinite? When we have limited channel bandwidth, we will lose the signal because of the channel constraint. Okay, that's why we there is a need of band limiting process, that is called band limiting process. In band limiting process, what will we do? That suppose we have a sync function, and then we have to multiply with a low pass filter. This is our signal. Okay, this is signal in frequency domain. Actually, this is our signal in frequency domain, and this is the our filter. This is the low pass filter, and what after doing process with this filter, suppose this is 1 by minus 1 by tau naught, this is 1 by tau naught, then after process with the cutoff frequency is 1 by tau naught, and this is minus 1 by tau naught, our bandwidth signal will be like this. The signal, this signal will contain approximate 95.99% of the power of the main signal. It contains all the significant frequencies. Okay, we have to remove the insignificant frequency from the signal, so that we can transmit into the channel. Okay, this process is called band limiting process. Band limiting process. Okay, I hope it is clear now. Okay, next we will see the properties of Fourier transform. Properties of Fourier transform, which will be used in our communication system. First is duality. Most important property is duality property. What is duality property? Duality property tells about whatever we see in suppose we have a rectangular pulse, so then the Fourier transform of this rectangular pulse is sinc function, we have already seen. Then Fourier transform, suppose we write it into time domain, there is a time domain, there is a sinc pulse, then what will be the Fourier transform of this sinc pulse? Actually, this is rectangular pulse. We can see the Fourier transform of rectangular pulse is sinc pulse, and the Fourier transform for sinc pulse is the rectangular pulse. This is called duality property. Similarly, if there is an impulse signal in time domain, then what will be in frequency domain? There is a infinite step signal. Okay, and what will be the Fourier transform of infinite step signal? The impulse signal. This is the Fourier transform. This is called duality property. In first property, just we do mathematics. We are first going to second property. First, we will write the mathematics. Okay. Suppose for the mathematics, uh, we have to write del t. Del t. What will the Fourier transform for del t? That is 1. And what is the Fourier transform for 1 in our frequency domain? That is del f. Okay. I hope it is clear. Second, our property is frequency shifting property. Frequency shifting. Okay. In frequency shifting, suppose xt is our time domain signal and its Fourier transform is xf. And what will happen when we shift in frequency domain, that is f minus f naught? What will happen? We have to multiply exponential signal in time domain xt into e to the power minus j 2 pi f naught t. We have to multiply a exponential signal, then we will find shifting in frequency domain with f naught. Okay. Suppose we have we know that for 1 the Fourier transform is del f, but if we multiply with e to the power minus j 2 pi f naught t, then what will be the Fourier transform? That is del f minus f naught. Similarly, for e to the power j 2 pi f naught t, the Fourier transform is del f plus f naught. Okay. Since it follows our LTI property, then we can add both the signals and divide by 2. Then what will we get? E to the power j 2 pi f naught t plus e to the power minus j 2 pi f naught t divided by 2. Then in the right hand side, what will we get? Del f plus f naught plus del f minus f naught divided by 2. And what is this? Cos 2 pi f naught t. For cos 2 pi f naught t, our Fourier transform is del 1 by 2 into f plus f naught plus del f minus f naught. It means for a sinusoidal signals, sorry, this is cos f naught t, basically t cos f naught t 2 pi f naught t. And what will the Fourier transform? Fourier transform is basically two impulse signal. One is at f naught and one is at minus f naught. And amplitude, what will be the area? Half. Half is the area. I hope it is clear, na? Next, third important property is our modulation property, which is basically based on last property, modulation property. After that, we will see what is the modulation and types of modulation, whatever. We will continue from this property. Okay. Suppose our xt Fourier transform for xt is xf. Okay. Then xt into cos 2 pi f naught t. What will happen? Just uh, whatever we have done here, same thing we will repeat here, but for xf we will shift my x f minus f naught plus x f my f plus f naught divided by 2. I hope it is clear, because we can write it in that form. just we have multiply cos 2 pi f naught t, and we are already multiplying with here cos 2 pi f naught t into j 2 pi f naught t. It do, it is just it will provide us just suppose mm, shifting in frequency domain plus f naught and minus f naught. Same thing we have written here. It will provide actually xt into it. If it is not clear, I will write it for you. E to the power j 2 pi f naught t plus e to the power minus j 2 pi f naught t divided by 2. I hope it is clear. Then xt into this will provide this one, and xt multiplied by this will provide this one and divide by 2. Now it is clear, na? Okay. What is the meaning of this? Suppose we have xt, suppose our message signal is t mt, and this is our message signal for minus tau by 2 minus tau by 2. Okay. Then in frequency domain, what was the Fourier transform of this message signal? Just after band limiting. Okay, just right here 1 by tau minus 1 by tau, and this is our 1 sorry f, this is our mf, this is 1 basically. Okay. Then after multiplying with this with cos 2 pi f naught t, what we are doing here? We are just multiplying this signal with cos 2 pi f naught t. Then in frequency domain, what is going to happen? We are just shifting in frequency domain. What we are doing? This the Fourier transform of this signal is just this one, and Fourier transform of this is two impulse signal. In multiplying actually in multiplying in frequency domain, in Fourier time domain, in frequency domain, what we are doing? Just shifting this mf into these two position. At mf, the central frequency is minus f naught, this is our and plus f naught, this is our basically mf, na? This is this one, and this is the copy of that one. This is our modulated signal. What we will write, just suppose we are writing here YF at 0. It means, and what is this? What we are doing basically, we have just shifted the message signal at frequency f naught. This process is called modulation. When we shift the low frequency signal at some central frequency f naught at high frequency is called modulation. I hope it is clear. If you have any doubt, then please write in chat box. I will try to clear that your queries. Okay. So then here we can write that modulation. What is modulation? Modulation is translating the signal from low frequency to high frequency region. Okay. And second thing is baseband signal becomes the passband signal. I hope it is clear, na? This is basically baseband signal. Now it is passband signal. For okay, one more thing I have just here to want to mention here. What is demodulation? Demodulation is basically to reconstruct the message signal from modulation. For today, I am stopping here. Okay, and uh, if you have any queries, please write in chat box. Thank you for watching.